Afternoon, good morning, wherever you guys are. Let's get to it. Apologies for the background noise. It's downtown Seattle, so. All right. So what are some of the technical challenges that we look at today, right? In terms of database, relational databases, or even a data warehouse like Redshift, right? I think the first thing that comes to mind is you're maxed out on your database instance, right? For example, let's say you have a 16x large instance and you want to go to the next level, right? You want to upgrade or scale up to the next level, if you want to put it that way. Scaling up is not cost effective. It's going to be super expensive. It's pretty much almost double your cost. And then I think one of the questions we get from our customers is, hey, how do we ensure that we run our workloads at an optimal level and at the same time keep a check on the costs, right? Because it is an important factor to consider. The other one I would look at is I've noticed applications generate duplicate queries, and in the other sense, you'd have repetitive pieces of code running on the application, right? And that will actually invoke the database to process that again over and over again. So we want to avoid that, right? Maybe something like a query caching or a caching layer that would actually facilitate that, right? Because you don't want to run over the same tables over and over again. The other thing that comes to mind is there's probably a lot of connections in the back end, and then concurrency is something that most databases, at least in RDS perspective, can handle them. But it gets to a point when you have multiple connections coming in from multiple applications or services, that can be a problem for sure. And I think one of the biggest challenges is, and yet undermined, is the network latency, right? I think a lot of folks fail to understand the negative impact on network latency, especially when you have a round trip query, right? And this can actually definitely slow down the application. Let's move on. All right. So who's Heimdall Data? Heimdall Data is based out in California, Bay Area. They're an advanced ISV partner. We recently did an FTR with them as well, so they're certified. They're also part of the Amazon RDS service ready program, and they also are enlisted in the Redshift service ready program as well, right? So Heimdall effectively offers you a database proxy. That's it sounds simple, but it's definitely something that changes your application, the performance of your application, right? It sits between your RDS database and your application. One of the biggest benefits from a customer standpoint is the customer is obviously going to get an improved SQL performance, and then that will enable you to not really scale up your database. Instead, retain your existing configuration and then allow Heimdall to sit in there and work its magic, right? We'll talk about the magic in some of the later slides.
Okay.
Like I said, the costs are also going to be significantly reduced, at least by 50%. Any questions so far, gentlemen?
No, it's going great. Yeah.
Awesome.
Small group, so feel free.
Yeah.
I did want to make a comment, since it is such a small group, going back to your sizing discussion. In particular for MySQL based systems, including Aurora for MySQL. We've actually had some customers find that trying to expand beyond a 12 extra large on, say, an R5 or M5, 12 extra large, or the R5 and M5 platform, they actually see a degradation in performance. So people think they have more room to grow, but they may not. And the reason for that is that those platforms actually are NUMA architected platforms. And once you go past the 12 extra large, it then has to share memory on the other core. That adds latency. It can actually slow things down overall.
Yep.
Okay, so people think they have more room to grow than they actually do in some cases. Now that doesn't impact Postgres as much because of the way the memory model works. I just want to call that out as a little tidbit for those that are here.
Right. Absolutely. Spot on, Eric. And I think one of the other things I've noticed is, I've worked on the other side, with developers in the past, and, every time they would hit an application problem, they would say, hey, you know what, let's bump up the resources. I'm like, that's not the answer. That's not the solution. Why don't we look into your application, look at the code and see what's going on, right?
Yeah.
There might be a problem or a logic in your application that you might have to tweak. And bumping up resources is always not the solution. Obviously, it's going to cost as well, but it's not going to solve your problem,
Yeah.
right?
I've actually,
Right.
yeah, I've seen the opposite happen as well. Many customers will see that they're using, say, their R5 for extra large instance, and they see it only running at peak at maybe about 50, maybe 60% CPU load. And they think, oh, we've got more room. Okay, we're not maxing that out. But what they're not paying attention to are factors like the IO volume that's going on to the back end. And by increasing the size, they increase the amount of memory. And by increasing the amount of memory, they allow more block cache to be stored. So sometimes people are keeping their instances artificially small, thinking that CPU is the only metric they need to care about. It's not.
It's not. It's a lot more. Yep.
Yep. Okay.
All right. So let me walk you through as to how Heimdall is basically deployed, right? There are two options. So if you look at the right, is the application. It's kind of a JVM application, and you can basically install Heimdall database driver between your application and your database, right? So you don't effectively replace anything over there. And I think the most popular option is the one on the left, where you have, obviously Heimdall supports Postgres, MySQL, MariaDB, and SQL Server, right? And it kind of speaks with the specific database protocol that is compatible with that application, right? So think of it as sitting between your application and your database layer, right? Or a persistence layer. That's where Heimdall fits into your ecosystem. Now, in this slide, we're going to talk about, some of the AWS services supported with the Heimdall Proxy. Obviously, for query caching, we kind of support the Amazon Elastic Cache. And then we provide caching and validation logic as well, right? And what is Elastic Cache? Of course, a lot of people, you might have been familiar with it, but if not, Elastic Cache is more of a web service that kind of makes it really easy to deploy and run Memcache or Redis protocol compliant server nodes right in the cloud. And Elasticache improves, the performance of your web applications by allowing you to kind of retrieve information from a fast managed in-memory system, right? So Heimdall definitely supports tweaking your queries running on Elasticache. The other service that they integrate with is CloudWatch, which I'm sure all of you guys have heard of. CloudWatch is, essentially a monitoring service, right? So basically, every AWS cloud service is integrated with CloudWatch, and it kind of records operations, stores logs, and you can also trigger alarms as well, right? So Heimdall fits in with that. And then, of course, the RDS database, right? Relational database. And what is an RDS database? It's more of a managed service that makes it really easy to set up and operate and scale your relational database workloads. And I'm sure you are aware of the fact that RDS supports a few flavors like MySQL, MariaDB, Oracle, and SQL Server, and Postgres as well.
Yep. Okay. Sorry to interrupt you,
Yep.
Anthony. I have a few questions here.
Sure.
And a few months before, back like 2 months, I tried to like integrate the Heimdall proxy, right? I got in touch with the support also. Right. See, we are running our production system in Aurora, and that is R5 XL in size, right? And that is a single instance, single master instance currently running. And we are what we are trying to do. We are trying to do like add a one read replica over there. We tried some earlier SQL proxy something. There is one more proxy, which
Yep.
is something SQL proxy, something like that. But we were having issue with the latency. Sorry, replica lag. When there is a replica lag, then that time we are not getting the most recent updated data from the read replica, and that proxy service were not able to handle those that kind of situation. And we found that the Heimdall promise like these kind of situation that can easily handle, right?
Right.
And we tried that in our staging server, and we found yes, it is handling, right? But we uh, uh, when we try to connect with the elastic cache, we try to use the elastic cache as a structure in the top of the
Yep.
RDS, right? So we had some issue over there. Like I don't know, means we are not able to troubleshoot that. What kind of means why that is generating? We are not getting the recent data. Like if a data is updating into the table, right? Then if the reader is reading from the elastic cache, so that was not able to get the most recent updated data. So what do you think, means what kind of problem they we may have, means it may be the size of the elastic cache, or what you're going to suggest, like if we are running our master and 2x R5 2x large, so what will be an ideal size for the elastic cache we should go with?
Okay. So let me step in as I'm actually on the support side, and I'm
Okay.
looking through. I'm not. Did you actually open up a ticket on that once you tried to use Redis or Elasticache? Because I'm not seeing anything in the threads that were copied to support. It's
Uh,
yeah.
okay, I'll get in touch with the support also that
Okay.
time. Yeah.
Okay. It sounds like the communication with Redis may not have been working appropriately. We can diagnose that in the past, say, month or so. We've actually included some patches that help to track the behavior of how Redis is working.
Okay.
So that may help in diagnosing what the problem is. But the way that Heimdall works is that when, let's say you have two proxies, it will use the pub sub interface of Redis in order to pass in
Right.
validation messages. So before the write happens against the database, Redis will send a notification to the, or Heimdall will send through Redis the invalidation notification for a particular table. That will tell the other proxy that, hey, a change is about to be made against this table. And for a
Okay.
period of time, it will not use that table, or it will not use the reader for that table, and it will not use the cache for that particular table.
Okay.
So if those invalidation messages are not getting through appropriately, then what could happen is one request would go through on one proxy that is doing a change against the table, but the other proxy is not aware that that change happened.
Okay.
Okay, so it's just about debugging why that communication is not working properly, and we can work through that on the support channels.
Okay. Okay.
Okay.
See, it is still in the staging environment over, so we'll move. We have planned to move in most probably in a few months. We are going to move it on our production.
Okay.
So
Great. Yeah.
before that we can do it. So what you suggest, like if we are going with the 2.5 like R5 X large, so what kind of means elastic cache size? What kind of what you recommend? Like what should be the good size of elastic cache?
At that, with that size, almost any Elasticache is big enough.
Okay.
It's when you get into very large deployments that you need to start worrying about tuning the Elasticache size. But we also have the ability to, for example, only use the Elasticache as a pub sub interface. So if you have a very large deployment that is ingesting large numbers of objects every second, you can actually turn the ingestion off on the Redis side, the Elasticache, and just use it as an invalidation interface. And as such, you can keep the Redis instance small, even in that type of case.
Okay.
Okay.
Great. Thank you.
Ravi, can I ask you a question?
Yeah. Can I have a quick question here? It's not support any Redshift on AWS.
We do support Redshift.
It does.
Yes, we're Redshift ready. We're certified by the business group.
Okay. So maybe I will not learn much in the later slides here. Elasticache itself with Redis or other things itself is a caching thing. So then why the proxy doing an additional thing here? I wanted to know.
Okay. One way to look at the proxy is that it's acting as a traffic director. It provides the intelligence that understands what a SQL query is and what a SQL result set is based on the protocol of the database itself. Elasticache is the cache. It's an object store. So it stores the data, it allows retrieval, and it can do a lot of other things at the back end, dealing with duplication of the data. You can have a global data store. There's a lot of other aspects of the Elasticache functionality that can supplement the functionality that Heimdall is providing. But what Heimdall is not doing is reinventing the wheel for all those aspects that Redis does well. Okay.
So the data that's being cached is actually sitting in Elasticache or is sitting in a Heimdall proxy?
It handles both sides. There's an L1 cache you can think of in the proxy and L2 in Elasticache.
Oh, okay.
Okay. Yeah, I guess I don't want to jump into my use case. Okay, which is on the Redshift side, pretty large size. So I need to know some of the internals and also the volumes currently handled in your clients or the tested one.
Yeah, we can get into a lot more detailed questions and test cases. We have a small enough group. Why don't we let Antony get through his section? We'll get into the demo, and then we can dive into as deep as you want. We've got plenty of time, I think, to dive into all the questions and use cases you guys may have.
Yep.
Okay.
Yeah, Ravi. And let's park your questions for Redshift. You know, I've worked as a Redshift database engineer for years, so I'd be happy to help. Get you kickstarted. If you haven't used Redshift before, I would love to share some links on some of the best practices using Elasticache as well, right? There's a lot of ways you can look at tuning your application. So Heimdall offers a lot. And at the same time, you also want to make sure that you have your sources, tuned as well, right? Because otherwise you're shooting the blanks, so to say. But definitely we'll talk about some of these use cases as we go on, right?
Okay.
All right, so let me see, what slide are we looking at? Okay. So yeah, like I mentioned, we Heimdall does support Redshift, RDS, Elasticache as well, and it's easily integrated with CloudWatch. All right. Again, we were talking about the deployment model, right? So like I said, Heimdall Proxy sits between the application and the database, right? And think of it as a layer kind of sitting in between your application and your persistence layer, right? So that's what it is. And with that, I'll hand it over to Roland.
Okay. Thank you, Antony.
Yep.
Hi, everyone. I'm going to just continue on the presentation. I'm going to make it rather quick because I'd like to have you guys get into the lab and get your hands dirty. And that's where you're going to learn a lot. So we're going to put a lot of emphasis on the online lab. As I'm pulling up these slides, any particular questions that Antony has presented that you would like us to answer in the meantime, as I'm getting the slides up?
No, not at my end.
Okay. So I'm going to pull up my slides here. All right. Okay, bear with me a second. Let me share screen. Let me know when you can see.
Yep, I can see it.
All right. Okay. So, Antony, did you speak to this slide already?
Yep, I did.
Okay, let's go to the next slide here. This is an educational presentation here, so we want to be fully open and just in the principles of AWS, customers first. So we want to give you full visibility, full amount of data so you can make an informed decision, whether it be the Heimdall proxy or another proxy. And this gives you an analysis of the database proxies out in the market today. What you will find, let me just name some of them. There's an AWS RDS proxy, there's PG Bouncer, there's Proxy SQL. The two in the middle are open source. The two in the middle, Proxy SQL and PG Bouncer, are database specific proxies. Okay, so I'm going to start with the right. The RDS proxy basically supports connection pooling. So if you're looking for a connection pooler for Postgres and MySQL, because those are the only two databases that it supports, then that may be just fine. And you may just want to use the RDS proxy. Okay. For PG Bouncer, the same thing. It is Postgres specific. And it's an open source pooler. It's free. Okay. But you get what you pay for. Okay. It won't have the fancy GUI interface. It's not as manageable, easy, but hey, you get what you pay for. Proxy SQL is the same thing, very popular in the MySQL community, but it's good in its pooling, but it doesn't have these other features that Heimdall Data, the Heimdall Proxy supports. And I want to get into that really quickly. And there's a lot of features, but these are the main ones that I want to highlight because they're difficult technologies that we've solved and it takes us years to perfect. Not only do we support connection pooling, but if you also want to split your reads and writes, and we call it read-write splitting or query separation, query splitting with ACID compliance. Okay, so as you know, when you split the queries to the writer and the readers, there could be, from an architectural standpoint, data consistency due to synchronization delays. So if you have a write followed by a quick read, that reader instance may not have gotten the update yet. So as the application is pulling data from the read replica, it may be stale data. That may not be something that's tolerable for your application. In this case, we support read-write splitting with ACID compliance, if that's important to you. Okay. Number two, we support automated cache invalidation. This is something that's very unique in industry. So you can have a cache subsystem in minutes as opposed to taking a year to build. Okay. The other benefit of turning this feature on, is that you don't have to do any maintenance. So typically, not only do you have to develop a cache subsystem, but you have to maintain it, fool around with the expiry or the TTL, with different cache rules and queries and everything as your application may grow and change. You don't have to do that with the proxy. We will adapt to the application, the dynamics of the application as it shrinks and grows, and cache the queries that make sense to cache, the duplicate queries, and invalidate when there is an update to the database table. Lastly, this is a little bit more for data analytics and Redshift, but it is appropriate for RDS and let's say Postgres applications as well. We can support LDAP integration. So if you want a centralized place for authentication, authorization for database access, we can do that against Active Directory. We can do that against LDAP, so that a single username and password you can authorize that to data for database access, and you can do that for groups, group extraction, a lot of fancy stuff. Again, this is for relational database for OLTP, but it could be also for data analytics as well. Any questions here on these various vendors and how we differ?
Nope.
All right. What we're gonna do is we're gonna go to one use case here, a business use case. This is the Grammys. This is the Recording Academy based out here in California. Their challenge was they were... Yes, sir.
Sorry, I'm on mute. I have a question on the previous topic. Do you authenticate SAML and do you authenticate Redshift accounts through your LDAP authentication integration?
I will kick that SAML question over to Eric to answer.
At the moment, we do not, although if you have a use case for that, we can entertain it. We currently have integration for direct LDAP support with Active Directory and Jump Cloud, as well as Open LDAP. So you can use any of those to do the authentication and authorization. We have group extraction capabilities. And then we can use the functionality that we have to synchronize the accounts into Redshift so that you don't have to have the accounts on Redshift to begin with. Now, we also do have something called, for the Postgres protocol, pass-through authentication. So if a user is on Redshift already, the proxy can use the database to do the authentication on our behalf, so that you don't have to configure the user on Heimdall itself. Okay.
Okay. So, okay. Yeah.
So Ravi, if SAML is important to you, just shoot an email to us and then we'll better understand your requirement and your use case, okay?
Yeah.
All right, any other questions on this slide? On the features? All right, let's move on to a success story. So the Recording Academy, they have RDS and they have 2 huge events. And during those events online, you have millions of users trying to figure out who won particular music genres. And their RDS was actually spiked at 100%. So the viewers could not see the live content, the updated content. And that's an issue, okay? That's a customer sat issue. So they chose Heimdall Data because we're able to offload SQL via caching and read-write split. And they love the fact that it didn't require any application changes. So we could scale their backend, offload the SQL to accommodate or to maximize RDS scale. And these are the benefits, and they're quite dramatic. The CPU was reduced from 100% down to 3%. Okay, and it's no exaggeration. This is all due to SQL offload. And the cache hit rate was 90%. So 90% of the SQL traffic wasn't even hitting RDS anymore. It was being serviced by Redis, Elasticache for Redis. And because of the offload, we were able to help reduce their RDS cost by 50%, because 90% of the traffic was no longer hitting RDS. RDS tends to be one of the most expensive AWS line items of your monthly bill. So that's for capital expenditure, but in terms of operational expenditure, it saved them months of development work of not having to develop these features. So they were very happy. Okay.
Great.
Any questions?
No.
All right. Now I'm just about done in terms of talking about the features. Does anyone have any questions about query caching or read-write split? Because if not, we're going to go straight into the lab.
So where will be actual do you have any kind of optimizer? So when a SQL is submitted, you said you have L1 cache and L2 cache. So I guess so you have an optimizer built in. Right?
We have a what?
To grab from optimizer.
Yeah. So let me tell you how we do it. So basically, all you have to do is change your endpoint from RDS to us. So it's clearly a networking change. So the application will think that we're RDS. Okay, we just sit right in the middle between the application and the database. Now, if you choose to deploy caching, not everyone needs caching. If you choose to deploy it, then what happens is you connect Elasticache to us. And what we're going to do is we have learning algorithms that determine whether or not this duplicate repetitive query should be stored in cache. If it's a hot object, it will be stored in what Eric mentioned, L1 cache, which is the EC2 in memory. That's the hot object. Anything that's remaining would be stored in Elasticache.
So a quick question then. So the endpoint is not to the NLB, or I thought, so the endpoint is actually directly to your proxy?
Okay, let me clarify a couple of points on this discussion. Going back to the question that was just presented, do we have an optimizer? Okay, I think the implication of that question was, are we rewriting the queries to make them execute faster? And the answer is no. We're storing the result of the execution and then using that to return an answer when the same query comes in later, so that we don't have to execute it again at all. The next question, dealing with the endpoint. In this, as diagrammed on Roland's slide, if you are using this configuration, then your endpoint would be NLB. However, we do have other configurations that actually allow you to do load balancing and other methods. For example, we actually have a built-in DNS resolver that would allow you to use NLB to load balance DNS requests to the Heimdall proxies, and they would hand their own IP addresses back based on load. And that would allow the application to connect directly to the proxy nodes, bypassing NLB. There are various reasons why you would want to do that, but one of those is that NLB has a cost associated with the traffic load, and it allows you to bypass NLB for the vast majority of your traffic. So there's lots of ways to do it. The question is, how do you want it done?
Okay, so let's say, I want an efficient, fast way, we really need to have the caching. We are B2C. So what would be the recommended way?
We'd have to look at your actual needs, and the scale applies. For example, when you're using the DNS resolver mechanism, it really mandates that you have a large number of application servers so that the DNS resolution over time provides a fair distribution of traffic. If you only have, say, 3 application servers, then using DNS to load balance against the proxies isn't going to work very well. Okay, so there's a lot of scale related issues that come into play.
Okay, got it. Thank you.
Okay.
Okay. Any other questions about read, write, split, and caching? I do have a couple slides on it. Otherwise, we're going to go straight into the lab. Okay. So, Ellen and Ravi, are you guys prepared to go to your environment and to do the hands-on lab?
Yeah, I am.
Okay. Ravi, you are as well? Okay, so
Yeah,
my last slide here is basically, we have a bunch of blogs, educational blogs. So when you go into the blogs, APN or the database blog, just search on Heimdall Data, and there are a bunch of how-to blogs. Okay, and from that, oh, in my emails right here, roland@heimdalldata.com. And if you have support issues, support@heimdalldata.com. And I believe we are ready to go.
Hey, Roland, could you copy those links and put it in the chat if you don't mind?
Sure can, sure can.
It looks like we have someone else just joining, Randy. Not sure if you're up for the demo part, but we just concluded the slide presentation.
Randy, hi. Are you familiar with the?
Actually, he's not on audio yet.
Okay. All right. So why don't we wait there and let me get you the blogs. So we get ready there. If you don't mind. Guy, Eric, what can they do to set up in the meantime?
I just started sharing my screen with the instructions.
Okay.
Okay. In the instruction link, let me actually chat. I don't know why Zoom hides the chat window when you start sharing on another window.
Yeah, it's annoying.
But just to make sure that everybody's got it, I'm not sure whether you can see the instructions if you joined late. But the instructions that I'm going to follow are available in the S3 bucket. And if you just use that or copy that down, then you'll be able to follow along with what I'm about to show you. Okay, I'm going to start off here. Now, if you're following through and actually setting everything up, I've pre-configured the CloudFormation template with an AMI ID that is only in US East 2. So if you want the easiest setup, make sure that you're operating out of US East 2, but I'm going to show you what you can do to alter that as we follow along. Okay, so let's go to the console. Now let's go to the region that you're going to deploy in. Now, the first thing that you're going to do, if it's a region that you're not normally using, you're going to want to make sure that you've got a key pair created, because we're going to need that as part of the CloudFormation deployment. So if you don't have it, create your key pair, make sure that it's ready to go, and we'll go from there. Now, an interesting little tidbit for anybody that is doing lab work and such. If you're familiar with the Graviton 2 instances, we're actually going to be using those for the database and Elasticache. But if you do any testing with Graviton 2, I'm going to give you a little trick that people don't know about at the moment. Antony, I'm not sure if this will be new to you. The Bangalore region has the lowest cost Graviton 2 instances by about 25%.
Oh, okay.
Okay. It's the only region that has the lower price. And that's as part of an initiative to see what type of adoption rate change occurs as a result of lowering those prices. So if you're doing lab work and you can do it on Graviton 2, then the Bangalore region is the lowest price place that you can do it in. Okay, just a cool little trick for everybody that may save you a little bit of money. Okay, so the next thing that we're going to do is we're going to go to the Heimdall Marketplace. The first thing that we want to do is ensure that you are subscribed to the Heimdall Proxy Edition. Okay, and then if we continue to configuration, we're going to see an important piece that if you're using something other than US East 2, you'll need to make a note of. If you look at the region here, if you go say to Ohio, you've got an AMI ID, and that's already pre-recorded as the default in our CloudFormation template. If you're running if you plan on doing the configuration anywhere other than Ohio, please make a note of this AMI ID because you're going to need it in just a few minutes. Okay. And that is the proxy edition AMI ID as represented in the in each availability or each region. Okay.
Okay.
But we're not going to continue on to launch yet. Okay. So now we're going to go to CloudFormation. Let's go back to your AWS console. Go to CloudFormation. And I'm actually going to delete this one for now. Okay. Again, within the instructions, you'll see that there is a URL for the demo-dependencies.yaml. What you're going to want to do is go to Create Stack, go to With New Resources, leave it as an Amazon S3 URL. You're going to enter in that URL for the demo dependencies. What this demo dependencies will do is it'll actually start an Aurora for Postgres cluster with a single node, C6G large. It'll also start an Elasticache instance, also using the C6Gs. These are Graviton 2. And then it will start a Heimdall instance. And while we support ARM, we are actually going to be using a C5 instance for this, for reasons I'll explain later when we actually get to the application installation. But we do support ARM as well. And many of our users, our higher volume users, are using the ARM to reduce their costs. Okay, so we're going to go to next. The availability zone. I'm just going to select, say, 2A for now. I'm going to leave the cache node type as the large. For reasons because they're predefined in some of the scripts, you'll want to use Heimdall test1, which is the default master password here. You'll want the master username to remain Postgres as well. Otherwise, some scripts will fail later. Database node type, again, I'm using C6G large. And here is where you'll put in the AMI ID if it's different, if you're using something other than Ohio as your region. You'll then select your VPC ID that you want to install everything into. And here's where you put in the key name that I asked you to make sure that you had available earlier. Okay. So,
okay, great.
So with this, we can go to next. Oh, wait, and make sure to create a stack name. Oops. I'm learning to use a brand new keyboard, so repetitive strain injuries are a pain, literally. Okay, so just click through to the next screen. You're going to have to scroll down to the bottom. We are creating an IAM role for Heimdall in order to access the configurations, which will be involved in the wizard configuration. So you'll have to check to acknowledge that we are creating an IAM role to access data within your account. And then we create stack. And now this process is going to take probably about 6 minutes, at least in Ohio. If you're in US East 1, it may be longer, just because it's US East 1. Surprise. Now, one thing I am going to point out, we've already got some resources created. It's creating Elasticache, but there is an Elasticache or Redis parameter group that is created. I'm going to open up Elasticache over here. I'm going to open this into a new tab, and I'm going to explain the one piece that we create here. If we go to the parameter groups, here, there's a particular function of Redis that not a lot of people are very familiar with. If we come here, it's generally on the 3rd or 4th page. And notify key space events. Now, the parameter group we create is setting this to a value of AE, which is not the default. It's the only parameter that we change by default. And what this is it's configuring Redis to notify listeners about changes to the keys that are within Redis itself. Now, what this does is it actually allows Heimdall to keep track of objects that are present within Redis. So we keep that as a list. And we do a lookup when we say data is not in our L1 cache. Do we need to ask L2, the Redis instance, if it has a copy of the object? Because we keep a track of all the keys that are within Redis, what that means is that we never have a cache miss against Redis. It's only cache hits. If Redis does not have it, we bypass asking Redis completely because it's just going to be a mess.
Quick question, it's the keys or tokens?
These are the keys. So when you just think of Redis as a key value store, we will have a copy of all the keys in Heimdall itself all the time. We won't have the values, just the keys. Okay, but we know if those values are there, so we don't have to ask Redis if it's not in the list. Okay, and this is very important in leveraging Redis as an effective L2 cache, because otherwise we would have to go to Redis every time to say, do you have it? Do you have it? Do you have it? And unless the cache hit rate is very high, you do not get the benefit of caching because you're adding the overhead of extra round trips. And if it's a miss on Redis, you just have to go to the database anyway. So this is actually, from our perspective, one of the most important things that you need to do in order to get benefits out of Redis if you're using it. Okay, so if you're using Redis within your own application, you may want to take a look at this.
Okay, great, thanks.
Okay, it's a great little optimization that you can do to just keep track of those keys. Okay.
So what is the recommended value for it?
You can look it up, but AE tells I'd have to look up what that means, but it basically says through the pub sub interface, tell all listeners about all key changes. So if you add, delete, change, whatever, any key, then the information is sent out through the pub sub interface, and you can keep track of that within your application. Okay. So we are still in the process of setting everything up. We should have maybe about 2 more minutes to go. Okay, and actually the create is complete at this point on the central manager. It's still waiting for some of the other small pieces, but we can come back over to EC2, open link in new tab. I'm going to come over here and we can see that we now have our Heimdall Central Manager instance. Now, there's a public IP associated with this. I'm going to open this up in another window. Control V :8087. Okay, and that gives us a login. Now the default user is admin, and the default password is the instance ID of Heimdall. So I'm going to copy that instance ID. I'm going to come in. I'm going to create, commit. Great. Okay, and I'm now in the Heimdall Central Manager. Let's come back over to our CloudFormation template. Let's look at the resources. Okay, it's still waiting for the database to be created. So let's wait before we do the next step for that to complete. And actually, I'm going to do another step while we wait for this. If we come over to Heimdall and go to the admin tab, I'm going to show you how you can actually update to the newest version of code. If you wanted, right now, we're already on the newest release of version of code. But what I'm going to do is I'm actually going to download the development version. This is completely optional for you, but it does have some things that make it a little easier to understand what's going on. So I'm simply going to select that development build and click Update Heimdall. And it's going to pull the most recent build that's available that's past minimum regression testing. And it's going to pull that down and install it automatically. It's now restarting the central manager. Good. We're just going to refresh. Refresh, and it should be done installing in just a few moments.
So the password to this central manager can be changed in the future, right?
Yes. If you go to the users tab,
Uh-huh.
you can change it right here.
Okay.
Okay. It just defaults to using the instance ID because that's a default that's easily available within AWS, and it's considered cryptographically secure. Okay. So it makes a great default. Make sense?
Yep.
Okay, great. Okay, so obviously nothing's going on here. Let's go back to our CloudFormation and we're done. If we look at the CloudFormation events, you can see that the entire stack has now been created and create complete is showing on the stack. So we're going to go back over here. We're going to go to the wizard. Now, if you click on the wizard tab, if it does not show this AWS detect button, just refresh the screen. Okay, sometimes it does not show up, although it's rare. We've got a ticket set up to fix that, but all you have to do is refresh the screen to get that. Okay, at this point, what I'm going to do is AWS detect. Now, what you'll find here is that the cluster that we just created as part of the CloudFormation template is now listed. Same for Redis. So I'm going to go on over here. I'm going to go to RDS. I'm going to show you what was created so that you can associate all these together. Okay, we go to DB instances and you can see Heimdall test2 DB cluster and then a random ID was created. All good. Okay, and that is now what I was able to select from the dropdown. So this is where the IAM role comes in. The IAM role allows us to pull the configuration of the RDS cluster and Elasticache cluster. It gives it to you in this convenient drop-down list. And then when we go to the next page, it's already detected many of the options that you need, except for things like the password, which is not available. Now, the password, if you recall, was Heimdall test1 with a capital H by default. And I'm also going to set a default database here of Postgres. Okay. And that's all I need to configure here because everything else is pulled from the configuration. I could enable load balancing, although I don't have a load balancing cluster set up at the moment, although obviously you can now add nodes, but I only have one writer node. But you know what? I'm going to turn on track cluster changes as well. Okay, that won't hurt anything. My Elasticache for Redis configuration, it's already put in the appropriate hostname and port as well. And then I can come through, enable the proxy. I want to leave all these options default. I would also leave all these other options default for the moment. For properties and rules, we're going to follow through with those defaults. And then we're going to review.
Can you select the query plan extract? We're interested in the plans.
You can. It will create a rule. It just won't enable it. And we'll get to that point later. If you want to enable it, I'll show you where you can do that in a moment. Okay. We're going to do next and submit. Now what I'm going to do, because I had updated the software, but I did not refresh the screen, I'm going to refresh and it's going to show all the various options here that are available. We can double check everything if we open these up as well. Now, the first thing I'm going to do to verify that everything is working right is I'm going to go to data sources and I'm going to do test connection. And everything tested. We can also look down at the load balancing and high availability. And we're going to see that it has everything pre-configured. It has the writer link and that has the reader. This is to allow read-write split, although we only have one node, so that's considered reader one. Okay, so you'll notice that it's actually the same name instance. Now, I'm going to go into one little piece about how Heimdall handles things with RDS and Aurora that it can be a problem for people. Well, it's not that we're causing a problem, it's that we're solving a problem. If you go over here to your RDS configuration and look at the writer, okay, that's great. And we can obviously add a reader as well. But what if you have, say, 10 readers? The way that RDS works is that it gives you a cluster endpoint. So you have this read-only endpoint that you can connect to, and it will send your queries or your connections to a reader. The problem is that this is done at the DNS level. And this URL or this host name will only resolve to one IP address at a time. If you have a whole bunch of applications that try connecting at the same time, or if it opens a pool of connections all at once, because it does one DNS request and then opens up many connections, all those connections will go to the same reader. So it doesn't matter if you have 10 readers here, only one is going to get that traffic. If we come back over here and look at the host name here, this is not the endpoint URL. Okay, these are actually the URLs of the individual nodes.
Instances, individual instances. But I have a question here. Redshift don't have this Aurora interface.
It does not. So, okay, Redshift is different. It's a different beast. Okay, you basically it's generally a much lower volume on a query by query basis, but the cost of each query is generally much larger on Redshift. Okay, so you'll have one endpoint on Redshift in general, although you can set a replicated cluster on Redshift. And you can manually configure at the moment these, like you can have multiple reader endpoints that point to different clusters that are replicated on Redshift. Okay, although at the moment it does not automatically handle that. Okay.
Yeah, so who replicates? I mean, I don't have any solution for Redshift replication.
No, there is a solution now. Okay, I would have probably Antony. You'd probably have to help him out or provide some info on that. I believe it's a new solution. I'm not sure how recent it was.
I can talk to that, Ravi. Could you park that question on Redshift? We can take it off, at the end of the session.
Yeah, but you can create replicated clusters now. Correct. And then Heimdall can use that replicated cluster as a reader. Okay.
Okay. I'm working very actively on that Redshift. Okay.
Very good.
I was being told here that a feature that's not known to me or not released yet.
I believe it's a released feature. Antony, am I mistaken on that?
Yeah, I can confirm on that.
Okay. Yeah, I'm not the Redshift expert here, so not on that side, not on the back end. Okay. So within Aurora and RDS, this allows you to automatically and dynamically handle things. And by using this track cluster changes, if you add a node, which I'm actually going to do by the end of this, it will detect that new node is available and will automatically add it to your configuration for you. That's what this track cluster changes does. Okay.
Okay.
Okay. So we are now up to the point where we have created our data source. We've created the virtual database. We have the rules. Someone mentioned the extract plan option. In order to enable that, all you have to do is commit or enable and commit, and you've now enabled that. So it preset that up for you. For the moment, I'm going to disable that. The reason being is that sometimes there are certain queries that can generate an exception within the extract plan if we try to extract them. And with what I'm going to do next, that could be a problematic. Okay, so I don't want this extract plan enabled. And in fact, I'm going to do an initial data load with an application called Odoo. I'm going to disable caching and a read-write split because these are what I'm about to do. It's doing lots of schema changes, and that is not something that is typically done in conjunction with caching and read-write split being enabled. Okay, for Odoo as well, I'm going to want to come over here to the advanced features, and I want to turn on something called delayed transactions. Now, this is a particular feature that's very important for Odoo because it attempts to do everything it does in a transaction. And if you don't have delayed transactions enabled, a lot of our functionality for optimization will not work. And by simply enabling this, it magically makes Odoo work better. Okay, not all applications are going to need this, but if they do, no other cache can provide you with the benefits that no other proxy can provide the benefits that Heimdall does. Nobody has this equivalent functionality for any proxy, for any database. Okay, so now we're up to step number 11 on our list of instructions. What I'm going to do is I'm going to come on over here to EC2. I'm going to connect, and what we're going to do is, because we already have this resource available, I'm going to install Odoo on the central manager itself. Now, this is not something I would recommend you do in any sort of production environment. But for the sake of creating a consolidated demo, it just makes things easier. So I'm going to come over here. I'm going to put in EC2 user. And then I'm going to connect. Okay, and I now have my secure connection here. A lot of people are not familiar with the fact that they can just go through this connect. They think they have to go through PuTTY or anything. Because since this has been added, some people just haven't changed their ways. But this makes it a lot easier to gain access.
So we are, but the problem is in our UAT and production environments, we don't allow any console.
I get it. Okay, I'm just using it for now. Okay, this is a demo. Okay.
Yeah, that's fine.
I'm just gonna come on over here, copy. I'm gonna use the link that is included. It's gonna pull down the start Odoo script and then execute it. Okay, and what it did was it actually is installing Docker onto that environment, and it's putting Odoo into a Docker service. So it's kind of keeping it compartmentalized. Okay, and it also, as part of the script, it should have set up an Odoo user within the database itself. Yep. Create role. So the Odoo user that's needed for Odoo to run has also been created as part of that script. And you can look at the contents of that script just by downloading it yourself. Okay, now I'm going to take the same URL here, copy. I'm going to come over here. I'm going to paste, but this time 8069 is the port that Odoo uses by default. Okay, now I'm going to set a master password. I'm going to tell you guys the master password I'm using. It's actually going to be Heimdall test, or Heimdall test 1. I'm going to create a database of Odoo. I'm going to put in my email address. I'm going to set a password as well. And an important part is this demo data. Just to use Odoo as a demo application, it's important that you check this box. And now let's come over. We click on the create database, and we can come over here. And by the magic of pre-configured scripts, everything is ready. Okay, and the traffic that Odoo is generating in order to set up the database is now visible. We can come over here, drop down on our database on our analytics tab, click analyze, and you can actually see all the traffic that's happening as Odoo is initializing everything on the database. Okay, it's now done the initial setup, and it's now Odoo basically has all kinds of different modules that you can use. The easiest one that we generally use is the e-commerce module. We're going to click there to install that module. And again, we can come over and we can see the traffic that's being generated on the database. You can see the CPU load on the Heimdall proxy. That's right now, because the central manager, the proxy, and the application are all on basically a 2 vCore system. It can get a little intensive as it does the load. But everything is loading in. We just wait for a moment. And by the way, I am recording this, and I'll make it available on our YouTube channel on on YouTube. So if you guys want to follow along as well, again, after the fact, if you've gotten behind, then you can go from there.
Quick question, we're waiting for that. What about
Yes.
HIPAA compliance?
Okay, so all the data in Heimdall by default is data in flight. Okay, in addition, Heimdall supports TLS, so the application to proxy can be encrypted, and we can even mandate the TLS just by a checkbox here. And then we support all the driver options for requiring encryption, because we're using the vendor JDBC driver to actually connect to the database as well. Further, within the cache configuration, we have this PCI HIPAA option. When turned on, it basically does not store any data in Redis. It only uses it for messaging. That's something that I had brought up earlier, is that this PCI HIPAA option basically allows you to downsize your Redis instance so that it's only used for invalidation, not used as a store. So that helps to ensure it's a minimum number of places where data gets put. Okay, we do support SSL, however, here, so that even the connection to Redis would be encrypted. Okay. So now let's go back to our Odoo configuration. We can pick a theme. I'm just going to use the first one. And it's configuring the website based on the theme. And in just a moment, it will be done. And we now have our shopping website configured, preloaded with data. Okay, so we can click through. And if we come over to our dashboard, we can see that we've got some data here. Okay. Now I'm going to do one more piece. Line 14 on the instructions. There's a run load script that we can download. I'm going to download the run load script. Now, just to show you what this is doing, it's basically just doing wget in spider mode to pull down the shopping cart pages. So it'll basically spider through all these different items over and over again. Okay, every link that's on this page, it'll try clicking. So okay, so now that that's running, we can come over here and we can see that we've got traffic. Now keep in mind, this is a very bare bones configuration. We're not doing any caching. We're not doing any read-write split. We're not doing anything. Okay, not yet. So the first thing that I'm going to do is I'm going to come over here and I'm going to turn on the cache. Commit dashboard. And we're going to see the impact of caching on this. Okay, and you can see the average query time for the local cache coming out. Okay, as it settles down around 200 or a little bit less than 200 microseconds for cache hits. Okay, and you can see that that's lowering the overall response time, the blue line, compared with the response time from the database. Now, this configuration, because I'm using US East 2, and I am pulling from a very efficient database. Okay, if you use US East 1 as a primary location, your database queries are probably going to be slower than this. They're probably going to be closer to a 1 millisecond or higher. Okay, this happens to be a very efficient region, and the more efficient the region is, the less benefit you get from the caching. Okay, great. But we're still getting a significant benefit here. Okay, so we can pause that. So just to put this in perspective, again, our database, our total query time is coming down to about 400 to 500 milliseconds, sometimes even lower. Again, I'm going to turn off caching, and we're going to come back over here. And we're back around 800 milliseconds or microseconds. Okay, yes, sometimes it's dropping a little lower, but okay. But you can see the impact of the difference on the response time. Okay, yep. And you can also see the impact on the database itself, the queries per second. So we've reduced the load on the database significantly by enabling caching. Any questions here? Okay.
No. Yeah.
Great. Okay. So next, now we only have one database server at the moment. Okay, but let's look how it's configured. Okay, it's looking at it as if it were two database servers. It has a writer node that it's going to try sending the traffic to and a reader. So we can enable read-write split, and it'll actually use different connections for each set of data. So we can actually demonstrate read-write split even with only one node at the moment. And that's what I'm about to do. I'm going to commit. I'm going to go back over to the dashboard. And what we're going to see is that the purple line is the reader or the writer. Okay, the reader, yeah. Okay. So we're now again offloading traffic off of the writer database, assuming that we had two databases. Okay. Now I'm going to come in and I'm going to turn on caching at the same time as read-write split. Now, as our cache hit rate goes up, you're going to see the purple line is basically going to drop to 0. Why is that? Well, the cache is consuming the same queries that the reader would have been serving, because they actually are overall cacheable. Now, that does not happen in most real-world applications. You're going to have some queries that say contain a timestamp, and you never see the same query again. But those can be served out of the reader node, but they cannot be served out of the cache. Okay.
Yeah, usually the case, right? So because AWS also released some caching inside the client cache. When you run the same query, I was arguing, why do I run the same query? I run a query, waited 10 minutes and got the results. Why do I need to run again to show it run in 1 minute now? Okay, already spent 10 minutes in waiting for the results.
Okay.
And I have portfolio managers across me, they run different. They don't run the same thing again and again. It's a use case oversold, okay? So I'm really having the issue here, convincing the management why we have to rely on this caching when no two portfolio managers asking the same thing. One manager is asking for some stocks of IBM and all. Another manager is asking something else.
That not all workloads are going to use caching, but your example is a great example where read-write split comes in. You're going to offload the writer onto readers. One of the ways to look at read-write split, let's actually go over to the RDS, actually. Okay, let's go back over. Because there's a way to conceptually think about database clusters that I think makes it very interesting. Okay, if we come over here and then we say add a reader, which at this point I want to do as part of the demo anyway. I'm going to add a new reader. Okay. Reader 2, I'm going to use the same size. It's not publicly accessible. Oh, let's throw that in 2B. Okay, I don't care about performance insights. I don't want to do all that. You know what? Okay. So we're now adding in a new node here. That's a reader. Now, should you think of this as a full-fledged database node? Okay, in my mind, actually, no. I conceptually think of this reader as a cache of all possible result sets off the writer. However, just like a cache, it may be a little bit out of date due to synchronization lag or replication lag. So this reader 2 node, it can be invalid on a table by table basis. So what Heimdall is doing is it's using our knowledge of what tables are being queried. So let's pull this out. What tables are being queried in order to determine whether or not you should use the reader or not in order to service a particular query. So if you write against a table, we know it can take time for the reader to replicate off of the writer. So for a moment, it should use the writer to service that read queries. And that's what we do. Okay, so when you think about read-write split as just another level of caching, it's now the L3 cache, not the L2 cache or the L1 cache. It's the L3. But you can service any query out of it as long as the table is valid to be serviced from that database or that node. And that's how Heimdall operates. We actually layer our read-write split logic on top of the caching engine. And that's why no other proxy can reliably handle read-write split and guarantee consistency. It's because you have to be able to do caching first. Okay, otherwise you can't do read-write split properly. And guess what? We just added a new node to the database. Okay, Let's come over here. Now it's still reporting as failed, so it's actually not listening yet. But if we come on over to our RDS cluster, it's still showing as created. But within the API layer, we now know that that node is about to come online. So we've already added it in, but we're not using it yet.
Yeah,
Okay.
that could take longer time depending on your size of the database.
Exactly.
If you have 10 terabytes,
Right.
10 terabytes, the replica creating itself takes time.
You got it. Okay,
So-
but
so-
what this
go
is
ahead.
demonstrating is the ability of this track cluster changes to adjust to the configuration within the API layer of AWS itself. Okay. Okay. And if we refresh the screen now and look at load balancing, we now see that we have reader 2 as well. And then we can come over here. I'm going to turn off caching. We're going to come here. I think my traffic generator. Oh, there we go. Okay. And once the node comes online, we should have the green showing up. Okay. So any questions? Failed false. Actually, now let's go back over. And if we have new queries, new connections coming in, everything is already pinned on connections that are on the old reader, but new connections would be able to go to the new one. Okay.
Yep.
Yeah, Odoo uses connection pooling on its own. And so as a result of that, unless Odoo opens up a new connection, we'll continue using the old reader for the moment. But over time, it will add in a few more. Okay. Any other questions or comments? And we can start talking about actual individual user cases, I believe.
Actually, I do have a question. So back to the HIPAA question.
Okay. Now I'm going to stop recording at this point. So if you guys want to say something that you don't want a YouTube video, that will be available.